Hello guys, welcome to Mother Code Academy. So as you all know, we usually start with hash include ice cream using namespace std int main. So let's highlight the topic of the day. It's relational and logical operators in C++. Okay, the first thing we're going to do is we're going to see our relational operators. So we have 6 relational operators in C++. We have less than, have greater than, we have less than or equal to, greater than or equal to, not equal to, and what again? 1, 2, 3, 4, 5, 6. Yeah, they're complete. There are 6. Okay, let's see how this works. For example, if you declare a variable a equal to 10 and then int b equal to 10 again. So let's put c out a less than, let's start with this less than here, a less than b. So is a less than b? Is this 10 less than this 10? This 10 is not less than this 10, therefore we're expecting to see 0. If the result is true, the computer is going to display 1. If result is true, the computer display 1, else 0. So if the result is false, we're expecting to see 0. So therefore here, I want to see 0. Let's run the program. Can you see? We have 0 here. Good. So let's end line here. And let's come here. Okay. See out a, let's check the second one, greater than. A greater than b. Is a greater than b? So is 10 here as a greater than this 10 here as a? So this 10 is not greater than this 10 because they're equal, they're the same. So therefore, we're expecting to see 0 here too. So let's run a program. Let's compile and run. Can you see? We have 0 for the second one too. Then let's try again. See out. Is a less than or equal to b? So is my a, is 10 less than or equal to b? In this case, there are two things you have to understand. The first one is a less than b? Definitely a is not less than b. So are we going to see false here? No. Then you check the second one. Is a equal to b? Yes, a is equal to b. Therefore, we're expecting to see 1 here. So let's compile and run. Can you see? We have 1 here because a is equal to b. So less than or equal to, there are two conditions in the same place. It's either less than or equal to. So one of them can work. So the computer is going to check less than first. Is a less than b? If a is less than b, therefore this condition is true. If a is not less than b, it will check the equality sign. Is a equal to b? If a is equal to b, correct. If the two are not true, then we have problem. So now, if I put c out again, and I put a greater than or equal to b. So What do you think will be the output of this line of code? Write your answer in the comments section. Here, A is greater than or equal to B. My A greater than B? Is 10 greater than 10? 10 is not greater than 10. How about is 10 equal to 10 for this equality? Yeah, it's true. Therefore, we're expecting to see 1 here, just like the previous line of code. So now, if I compile this program, can you see? We have 1 again. Good. So, if I come here again and I check C out, I'm going to check equality. Is A the same thing as B? So the two equality sign means equal to in programming. This one, this single equality sign, it means that we assign 10 to A. We put 10 inside the container A. We put 10 inside the container B. This is the meaning of this equal to. But these two equal to means are the two the same? Is A the same thing as B? So yeah, the two of them are the same because they are both 10. So if, after compiling this program, can you see? We still have 1. This one means true. In the language of computer, 1 stands for true and 0 stands for false. So now let's try again. So let's check not equal to. See out. Is A not equal to B? So what do we expect to see the output of this program? The output of this is A not equal to B. A is equal to B, so therefore this is false. Meaning, is A not the same thing as B? They are the same. Then this line of code is 0, false. So can you see? We have 0 here. So as simple as you can see, this is relational operator in C++ or operators in C++. And after we're done with relational operators, let's see how logical work. So logical operators. In logical operators, let's create two variables. Let's say int x equal to 15, int y equal to 16. Let's try something like this. See out. Okay, the logical operators, there are 3 logical operators. The first one is or, the second one is and the last one is not equal to. This stands for not equal to. Yeah, all right. So here, if we have a number like this, let's say x equal to x is the same thing as 15 or y is the same thing as 16. So in this line of code, we want to check the logical operator or. Let me just give it a definition here. Let's say or requires one of the condition to be true for the result to be true. Yeah, if I want this line of code to be true, at least one of this one, either this one or this one of them should be true. Okay, so let's see now. Is x the same thing? This the same thing. You already know how this works. So like in this line 17, it's supposed to be this not alone here. And if I run this program, firstly, let me explain this. Computer is going to check if one of these is true. This is the nature of all statement. One of them must be true. If the two of them are true, it's fine. That's we want it to be like that. But if the two of them are false, then definitely this line of code is going to return false. For example, now, is x the same thing as 15? So let's check. X is the same thing as 15, yeah. Or is y the same thing as 16? So now in this case, the two of them are true. So we're going to see 1. The output is 1. So let's put in quotation. Output here is 1. Let's copy the same line of code here. Let's paste it here. So now let's change this one to this, like this. So see out, is x the same thing as 18? X is not the same thing as 18 because x is 15 in line 18. So computer is going to check the next one. How about this one? Yeah, it's true. The output here is 1 also. If we come here and paste again, let's change this to 15, that is true, and this one to 18, false. So is x the same thing as 15? So let's check. X is 15 in line 18. Yeah, this is correct. How about this one? This is false, but it is true. One of them is true. So therefore, we're expecting to see 1 if I run the program. Then the last one. Let's make them to be different and to be different here. So this is going to result to false because none of them is correct. X is not 17, Y is not 106. So the only way where O can be false is if the two of them are not true. This is false, this is false, then the result is false. But if one of them is true, the result is definitely true because we said O. How it works is that, for example, maybe you can say, I want a boy or a girl. So if a boy come, it's fine. If a girl come, it's fine. If the two of them come, it's also fine. But if none come, then there's problem. So that is how it works. So let's see this one. So can you see? 1, 1, 1, and the last one false is 0. So I didn't break line, that is why you see it like this. If I put M line, it will not be like that. So okay. So let's check. Let's check how the AND work. If we said C out, and we have something like this too. So now if we said C out, okay, C out, X is something as 15 and Y is the same thing as 19. So what are we expecting to see in this line of code? The AND function work like if this is true and at the same time this must be true for the whole line of code to be true. So in this problem now, this is true, but this is false. Therefore, we're expecting to see 0 here. So if I copy the same line of code, if I paste it here, and I make this one to be false and this one to be true, we are going to see 0 again because we want the two of them to be true for the entire line of code to be true. So on the last one, 15, let's make this one to be 16. Yeah. But before that, if you paste this one and you put different values here, 1919. So this is false, this is false, the entire line is false. This is true, and at the same time, this is true because x is 15. Can you see it here in line 18? X is 15, and y is 16. In line 19, y is 16. So only this line, the last one, is going to be 1. So if I run it, I compile and run, can you see? Only the last one is 1. 0, 0, 0, 0. Sorry, this 0 is not that one. This 0 is part of that one. 0, 0, 0, and 1. So that is it. And this not is negation. If you have, for example, see out x equal to 15 and y equal to 16. What do we expect to see as the output of this line of code? This is true because x is 15 and y is 16. But if we want to make this condition to be false, then we have to put this negation here, this exclamation mark. Then this exclamation symbol stands for check this condition. If the result of this condition is true, then turn everything to false. However, if the result of the condition here is not true, that is, if let's say, okay, let me run this one first. Can you see we have 0? We have 0. X is 15, yeah, we agree. Y is 15, 16, yeah, we agree. The two line of code, the two part of the condition are true, but due to this negation symbol, we have false, as you can see. Can you see? We have 0 here. So now, if I try to make something like this, let me copy this line of code. Let me paste it here. Okay, let's make this one to be 105. So this is false and this is true. The nature of the and is that the two of them should be true if we want everything to be true. But in this case, this is false and this is true. Therefore, the entire line of code here is false. But due to this negation, then we are expecting to see 1 that is true. Can you see it here? So I hope you guys understand how this works. In the next video, I'm going to show you, I'm going to explain deep on how this works, their power, that is the power of precedence, which one have more priority than which one, and how does computer execute this type of program or this type of problem, like how should I run this one, what should I do if this happens. So I'm going to explain more on this in my next video. I hope you guys enjoyed this video. Like this video, subscribe to this channel, and share it with your friends. Thank you.